Calculating elasticity. Straight line supply curves going through the origin have the same elasticity everywhere. But this isn't true for other supply curves. If they don't go through the origin or if they're not straight lined, elasticity can change as we move along the line. Now, if you're given percentage changes, just apply the basic formula. Percentage change in quantity divided by percentage change in price. If you're given unit changes, if I tell you price went from $10 to $11 and quantity went from 1,000 units to 1,200 units, then we need to do a little bit more math. Now, the problem, the trick in calculating elasticities is to recognize this. If I tell you that something went from 4 to 5, we say that's a 25% increase. If I tell you that something went from 5 to 4, then you would say that that's a 20% decrease from where we started. This means that we need to sort of think carefully about what our starting spot is and what our ending spot is. Fortunately, economists have developed a way to handle this problem called the midpoint method. The midpoint method looks like this. Essentially what we're going to do is, instead of choosing 4 or 5, we're going to take an average of 4 and 5 to decide on what our percentage change is. So our percentage is not out of 4, it's not out of 5, it's out of the midpoint between the two. What percentage of 4.5? So written in algebra, here's the term. Here's the basic formula for elasticity of supply using this midpoint method. Right? Q2 is our ending quantity. Where did we move to? Q1 is our starting quantity. So if quantity went from 1,000 to 1,200, this would be 1,200 minus 1,000. So our change would be 200 for 1,200 minus 1,000 divided by the average of 1,000 and 1,200, which would be 1,100. So our change would be 200 over 1,100, and this would give us our percentage change in quantity. We do the same thing for price. If it goes from $4 to $5, then we say that's a $1 change, 5 minus 4. And our price that we use to form the denominator is the average of 4 and 5. 4 plus 5 divided by 2. And that will give us our number on the bottom. So Q1 and P1 represent the initial quantity and price, where we are on the supply curve. Q2 and P2 represent the new quantity and price, where we end up on the supply curve. Here's a numerical example. So consider this supply curve here that we're looking at now, and consider the elasticity of supply between points A and B. Right? Our basic formula I've copied up here. This is the same formula from the previous slide. Now we're going to do this with real numbers. Right? At A, we have 20 units sold at a price of $3. At B, we have 30 units sold at a price of $5. Okay, so let's calculate elasticity. The elasticity of supply, the change in quantity, 30 minus 20, the ending quantity minus the starting quantity. Our increase, this is going to be an increase of 10 units. Divided by the average, 30 plus 20 divided by 2 is 25. So 10 over 25 is 40%. We've had a 40% increase in quantity by applying this formula. Compare this to the denominator, the price. We go from $5 to $3, so our increase in price is $2. $2 divided by the average of 3 and 5 gives us 2 over 4, or 50%. So our elasticity of supply, ES, is 40% divided by 50% equals 0.8. A note about elasticity, and if you look at the relative steepness or flatness of the supply curve that we saw before, you can see that elasticity is going to be related to slope. Elasticity and slope are going to be very closely connected to each other. Now notice that we can rewrite our formula for elasticity, the midpoint method, slightly differently, where this is the change in quantity divided by the quantity, in the case of the midpoint formula, the average quantity, the average of the beginning and ending quantity. So this is the change divided by, the change in Q divided by Q gives us our numerator. The change in P divided by P gives us our price, and then we can rewrite this expression just like this. But what does this look like? It looks a lot like a formula for slope, but in this case what it really is 1 over the slope. Right? Q is the variable on the horizontal axis, and P is the variable on the vertical axis. So this elasticity is 1 over slope times P over Q, times the relative price per unit. So So this formula here will tell us that elasticity is very directly related to slope. As the curve gets steeper, this is the numerator, this is the denominator. As the curve gets steeper, as the denominator gets larger, elasticity goes down. Right? The elasticity of supply will go down. The same will be true for the elasticity of demand. Right? As the curve gets flatter, as the slope gets smaller, the denominator gets smaller, means the elasticity rises, the elasticity increases. So a steeper curve is a lower elasticity, a flatter curve is a higher elasticity.